This is 2015 number 6, a non-calculator question. And actually, we can answer all 3 parts of this question. So we are going to go ahead and do that. It says, consider the curve given by the equation y cubed equals xy equals 2, minus xy equals 2, excuse me. It can be shown that dy dx equals y divided by 3y squared minus x. Notice that they had to use implicit differentiation because they could not solve for y. Luckily, they already gave you the first derivative, so you do not have to calculate it using implicit differentiation. Part A says, write an equation for the line tangent to the curve at the point -1, 1. So if we're going to write the equation of a line, specifically a tangent line, we need 2 things. We need a slope and we need a point. So to find the slope, we can use the derivative, and they already found that for us. So that was nice of them. And I'm going to find it at the point -1, 1. So all I have to do is plug in -1 everywhere I see an x, and plug in 1 everywhere I see a y, and that will help me figure out the slope of the tangent line, which is the derivative. So here's a y, I'm going to plug in 1. Here's 3y squared, I'm going to plug in 1. Here's x, so minus, and then x is -1. So my slope, if I simplify this, is equal to 1 over 3 plus 1, or in other words, 1/4. So there's my point, there's my slope, and I actually already have a point. They're giving me a point of -1, 1. So all I have to do is write it into point slope form. So y minus y1 equals m times x minus x1. And don't forget to do that plus symbol there. So that's the final answer here. And that is worth 2 points. Part B. Find the coordinates of all points on the curve at which the tangent line to the curve at that point is vertical. So this is kind of a conceptual question. Find all coordinates of the points on the curve at which the tangent line is vertical. Well, a tangent line that's vertical has a slope of what? A slope that's undefined. So I'm looking for where the derivative is undefined, or in other words, where this function is undefined. All right, so this is a rational function, and a rational function will be undefined wherever the denominator is equal to 0, and it will be undefined for one of 2 reasons. Either it would have a hole, or it would have a vertical asymptote, and one of those things will make it undefined. So for part B, I'm looking for where the denominator of this fraction, 3y squared minus x, equals 0. I want to know where that's true, because that will tell me where the derivative is undefined, or in other words, where the slope of the tangent line is undefined, which means it would be a vertical line. So if I solve this equation, I can add x to the other side, so I get x equals 3y squared. And I need to actually solve for this, because they want to know all the actual coordinate points. So at this point, we can use this. So we have one equation here. And notice that up here at the top in the directions, we happen to have another equation with x's and y's in it. So together, we can use both of these equations as a system. So I already have x equals 3y squared. Why don't I just take that and plug it into this function everywhere I see an x, and we'll just do it by substitution. So if I do that, I get y cubed. So I'm just rewriting this equation up here. Y cubed minus x, which is 3y squared. And again, I'm just doing that substitution from what we just figured out right here, times y equals 2. So I have y cubed minus 3y cubed equals 2. Therefore, -2y cubed equals 2. Therefore, y cubed equals -1. Therefore, y equals -1, because the cubed root of -1 is still -1. So there's my y coordinate, but I actually want both coordinates, the x and y coordinates. So I need to figure out how to go backwards, all right, and how to figure out what the x coordinate would be. So why don't we just use this one? You could use either one, the one up at the top or this one, but this one seems like the easier option. So I have x equals 3 times y squared, and we just figured out that y is equal to -1. So therefore we have x equals 3 times 1, or x equals 3. So my coordinate point is the point 3, -1. And at that point, the line that we have up above has a vertical tangent line, meaning that its slope is undefined. So that is 3 points. So far we have 1, 2, 3, 4, 5, and there are 4 more because each one is worth 9 points. So here are where the last 4 points come from. Part C says, evaluate d squared y dx squared at the point on the curve where x equals -1 and y equals 1. So d squared y dx squared means we actually have to find the derivative again. So they gave us the first derivative, they gave us dy dx. Now we have to go back and find the second derivative and then plug in -1 and 1 into x and y. So let's do that. We'll just do it here on this scratch paper. So let's take the derivative for part C. dy dx, so d squared y dx squared, which is the derivative of this, equals, and remember that we have to do it using implicit differentiation again. So the derivative, this is going to be the quotient rule. So the quotient rule, remember, is the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So we have the derivative of the top. So the derivative of y is y prime, or dy dx, times the bottom, so times 3y squared minus x, minus, so again, just to review where we got this, this is the derivative of the top times the bottom minus the top, so y, times the derivative of the bottom. So the derivative of 3y squared is 6y times dy dx. So that's the derivative of 3y squared minus x. The derivative of x, well, luckily we're taking the derivative with respect to x, so the derivative of x is just 1. All over, so again, let's review where we've gotten all of this so far. We have the derivative of the top, that's this piece, times the bottom, that's right here, minus the top, that's y, times the derivative of the bottom. Alright, so that's what we have so far. And that's all over the bottom squared. So 3y squared minus x quantity squared. So that's where a majority of your points are going to come from, is getting that derivative correct. I would highly suggest, if you don't feel comfortable doing that in your head, writing out u equals, v equals, and then take the derivative of the top and bottom separately so that you don't miss any pieces. Because the derivative, if you can't get that correct, they're not going to give you any of these 4 points. So you have to be really careful about that. So now let's plug in, everywhere we see an x, we're going to plug in -1. Everywhere we see a y, we're going to plug in 1. Now, I want you guys to kind of take a minute and think about this, because dy dx, I don't have any value to plug in for dy dx, but they do this a lot on the AP Calculus exam, where they will put an answer in a previous part of the problem and make you use that same answer down here. So notice that the first part says, write an equation for the line tangent to the curve at -1, 1. So we're actually looking at the same point. So dy dx is the slope of this line. So that means I don't need to calculate dy dx again. I can just use the slope from part A. So if you remember, the slope from part A was 1/4. So everywhere I see a dy dx in this problem, I can replace it with 1/4, because that is the slope of the line at -1, 1. So saves you some time. Of course, if you didn't realize that, you'd have to do it all over again, but if you do realize it, it saves you some time. So dy dx is 1/4 times 3y squared, so that's 3 times 1 squared minus x, which is -1, minus y, which is 1, times 6y, which is 6 times 1, and then dy dx, again, that's 1/4, minus 1, all over 3 times y squared, so 3 times 1 squared minus -1 quantity squared. Be careful, alright? I could easily see people making mistakes with this and not doing like minus a -1 correctly, or not putting parentheses in the correct place. So make sure you're very careful about that. So here we have 3 times 1 squared, so that's 3 minus -1, so that's 3 plus 1. So we have 1/4 times 3 plus 1, that's 4, minus, over here we have 6 times 1/4, that's 6/4 minus 1. All over on the bottom I have 3 minus -1, that's 3 plus 1, that's 4 quantity squared. So 1/4 of 4 is 1, minus 6/4 minus 1 is 2/4, or 1/2, all over 16. 1 minus 1/2 is 1/2 over 16. And if you multiply by the reciprocal, you get 1/2 times 1 over 16, which is 1 over 32. Final answer. So, lots of work. That last piece is worth 4 points on the AP Calculus exam. But again, a majority of your points will come from getting the derivative right. So, at the very least, make sure you get the derivative correct, because if you accidentally make a mistake plugging numbers in, at least they can give you a majority of the points for getting that piece correct up at the top.